Good morning, students. In the last class, we have discussed about the basic gates, universal gates, as well as special purpose gates. Right? So, which are basic gates? AND gate, OR gate, and NOT gate. Which are universal gate? NAND gate and NOR gate. Which are special purpose gates? That is XOR gate and XNOR gate. Right? So, we have 7 logic gates, which consists of basic gates, universal gates, and special purpose gates. Right? So today I'm going to discuss the pin diagrams of this logic gates. Right? So let me start with AND gate. So this is the pin diagram for AND gate. Right? So the IC number for AND gate is 7408. IC number for two input and gate. IC number is 7408. This is what is written here. IC means integrated circuit. Okay, it is a 14 pin IC. It is a 14 pin IC, right? So which will be having 14 pins. In that, pin number 7 is always ground and pin number 14 will be used for VCC connection, right? So pin number 7 is for ground, pin number 14 is for VCC, right? So if you observe carefully, just see here, this is pin number 1, this is 2, 3, 4, 5, 6, 7. See here 7 is connected to ground. Here it is written ground, right? And pin number 8, 9, 10, 11, 12, 13 and 14 is for VCC, right? So here observe carefully in this IC there is a U-shaped symbol, right? That should be always in this direction, right? You have to keep it always left side, this U shape, right? So when you keep this IC in the left side, from the bottom, you have to start counting the pin numbers as 1, 2, 3, 4, 5, 6 and 7. 8 starts from this side. 8 starts from this side. 8, 9, 10, 11, 12, 13, 14. Right? So here, how many gates are there? Just observe. Pin number 1 is 1 in first input of the first AND gate. So here how many gates are there? 1, 2, 3 and 4. Right? So in that pin number 1 and pin number 2 are the inputs to the first AND gate and pin number 3 is the output. There input 1, input 2 and this is output of the first gate, right? Pin number 1 and 2 are the inputs to the first gate and pin number 3 is the output to the first gate. So A, B are the inputs, Y is the output, should be connected to pin number 3. Next, in the second gate, pin number 4 and 5 are the inputs to the second AND gate and pin number 6 is the output of the second AND gate, right? 4 and 5 are the inputs, 6 is the output for the second AND gate. And I have third AND gate here. So in the third AND gate, see here pin number 9 and 10 are the inputs. Pin number 9 and 10 are the input and pin number 8 is the output for the third AND gate. And for the fourth AND gate, pin number 12 and pin number 13 is the inputs and pin number 11 is the output, right? So here in one IC, if it is a, just observe carefully all the gates which will be having only two inputs. So if it has two input means we can get four gates in one IC, right? Four gates in one IC, right? So it is a 14 pin IC. Pin number 7 is ground and pin number 14 is for VCC, right? Next, I'll just draw 3 input 3 input, gate, AND gate, right? So here I'll take color. So I'll draw here. So always U shape now should be in this direction, and this is the IC I'm going to draw here. 1, 2, 3, 4, 5, 6, and 7. Here I'm going to write 8, 9, 10, 11, 12, 13, and 14. So for 3 input, what is the IC number? It is 7411. So for 3 input, IC number is 7411. Right? Now, how to write 3 input AND gate? So here, for 3 input AND gate, first I'm going to take this as pin number 1, pin number 2, 1, 2, and 13 as a input, and pin number 12 will be the output. This is the first gate. And for the second gate, pin number 3, pin number 4, and pin number 5 are the inputs, and pin number 6 is the output. Likewise, here pin number 9, pin number 10, and pin number 11 are the inputs, and pin number 8 is the output for the third gate. Right? So always here, not in all the ICs, but for this logic gates, always this pin number 7 is for ground and pin number 14 is for VCC. Right? So here you observe carefully. So this is the first AND gate, second AND gate, and this is third AND gate. So for the first gate, pin number 1, 2, and 13 are the inputs, and 12 is the output for the first gate. And for the second gate, pin number 3, 4, and 5 are the input, 6 is the output, 7 is ground. Here for the third gate, pin number 9, pin number 10, pin number 11 are the inputs, pin number 8 is the output. Right? So if it is 2 input AND gates in one IC, there will be 4 AND gates. So if it is 2 input AND gate, IC consists of 4 gates. Right? If it is 3 input AND gate IC, which consists of how many gates? 1, 2, and 3 gates. Right? 3 gates. So this is for the AND gate. Right? Next I'll go with the OR gate. So OR gate, this is also same. I'm going to draw this as first gate, this as second gate, third, and fourth. Right? So here pin number 1, let me write it as first gate input. This is also first gate input. This is first gate output. Pin number 1, 2 are the inputs, and 3 is the output for the first gate. And for the second gate, pin number 4, pin number 5 are the inputs. 2 represents gate number 2, and pin number 6 is the output. See here, 7 is ground and 14 is VCC. Right? So for the third gate, pin number 9 and 10 are the inputs, 8 is the output. And for the fourth gate, pin number 12 and pin number 13 are the inputs, pin number 11 is the output. Excuse me. So here, if it is 2 input OR gate, how many gates it has in one IC? There are 4 gates. What is the IC number for 2 input? For 2 input OR gate, IC is 7432. Right? If it is 3 input, it is 74HC 4075. This HC tells family of the IC. Right? So here also in the lab, if you come, you will get reg 74LS32. So this tells the family of the IC. Right? So how to draw 3 input OR gate? So it is similar like AND gate. So how many pins? Total 14 pins. Pin number 1, 2, 3, 4, 5, 6, and this is 7. 8 you have to start from this side. 8, 9, 10, 11, 12, 13 and 14. As I've already told, pin number 7 is ground and pin number 14 is VCC. Right? So here pin number 2, 1 and 13 are the inputs for the first OR gate and 12 is the output. Likewise, for the second OR gate, 3, 4 and 5 are the inputs and 6 is the output. And for the third gate, 9, 10 and 11 are the inputs and 8 is the output. Right? So this is first, second and third. Right? So next I'll go with the NOT gate. So here, since NOT gate has only one input, there is no multiple inputs for the NOT gate. The IC number for NOT gate is 7404. Right? So if you observe carefully in this diagram, see here, U shape now should be this side. Pin number 1 should start counting from here till 7 and 8 starts from upper. So from this side, 8 till 14. Right? So here, since which has only one gate, one input. So how many gates are available in one IC? There are 6 gates are available. So here I am going to mark this is first gate, second gate, third gate, fourth gate, fifth and sixth. Right? Okay. So I'll draw this NOT gate IC, students. So what is the IC number? 7404. That is NOT gate. Right? So here I am going to draw. So how many pins? It is 14 pins. So here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14, right? So always 7 is ground and pin number 14 is VCC. So since NOT gate has only one input, so pin number 1 is input, pin number 2 is output for the first gate, right? And pin number 3 is the input and pin number 4 is the output for the second gate, right? Pin number 5 is the input and pin number 6 is the output for the third gate. And pin number 9 is the input, pin number 8 is the output for the fourth gate, and pin number 11 is the input and pin number 10 is the output for the fifth gate, and pin number 13 is the input and pin number 12 is the output for the sixth gate, right? So this is IC 7404. So how many gates are available in one IC? In one IC, 6 NOT gates are available, right? So this is the diagram for the NOT gate, right? So next we'll go with the universal gate. So that is Nand gate, right? So see here, just observe carefully students. For the Nand gate, 3 input AND gate and 3 input OR gate, the pin numbers are same. Like this, you have to draw 3 input NAND gate and 3 input NOR gate by yourself. I am going to teach you only 2 input now, right? So here for 2 input NAND gate, IC number is 7400, right? So here I am going to write. So this is first gate, this is second gate, third gate and fourth gate. So here pin number 1 and 2 are the inputs to the first gate. Pin number 3 is the output. So for the second gate, pin number 4 and 5, that is input. Pin number 6 is the output of the second gate, and pin number 9 and 10 are the inputs, and pin number 8 is the output of the third gate, and pin number 12 and pin number 13 are the inputs of the fourth gate, and pin number 11 is the output of the fourth gate, like this. So you have to draw for 3 input NAND gates. So the IC number for 3 input NAND gate is 7410, right? So next I'll go with the NOR gate. So here the IC number for NOR gate, 2 input NOR gate IC is 7402. If it is 3 input, 7427, right? So here I am going to write first gate, second, third and fourth, right? So here pin number 1 and 2 are the inputs of the first gate. Pin number 3 is the output of the first gate. Pin number 4 and pin number 5 are the inputs to the second gate. So here this is see here, this is just ulta. So better you do one thing. I'm going to draw here. You just take that pin diagram instead of this, right? So it is the direction and orientation of this gates. It is depending on the manufacturer, right? So I'm just going to draw that 2 input NOR gate also, right? So 1, 2, 3, 4, 5, 6, 7, 8 should start from here. 8, 9, 10, 11, 12, 13, and this is 14 is always VCC and 7 is ground, right? So pin number 1, pin number 2 are the inputs of the first NOR gate, 3 is the output. So pin number 4, pin number 5 are the inputs of the second NOR gate, pin number 6 is the output. 9 and 10 are the inputs and 8 is the output. 12 and 13 are the inputs of the fourth gate and 11 is the output. The IC number is 7402, right? So this is how we are going to identify the pin numbers for the gate, right? Now let me take one circuit. So for that, now we have to write the pin numbers, right? So let me take y is equal to a bar b plus b bar c plus a b c, right? Plus a c. So for this circuit, now I have to draw the pin numbers, right? I'll do some small changes. Small change. Okay. So here I'm going to write this as a b bar, right? So this is the expression. Now I have to draw the circuit. Now in today's class I have explained only two input pin diagrams and three input pin diagrams, right? So here based on that you have to you have to think and write the circuit now. Since I have taught only the two input and three input gates, right? So you cannot use 4 input gates now, right? Now I'm going to draw circuit for this. So this is a bar. So here it is a bar I'll get, and this is B. So this is for the first term. Second one is B bar C. I have B here. So I will just take inverter from here, and this is C. This is one AND gate. Next I have a B bar. So I will just change the color. A. So B bar, right? See here, I have B bar here. Output of this input of this inverter is B. Obviously output of this inverter is B bar, right? So here I am going to write, I'll write A bar. So this is B bar. Third one, and last one is AC. So already I have A here. This is A. This is B bar, right? So I'm going to take A from here, and I have C here. So this is one AND gate. Now you can use 3 input OR gate, or you can use 2 input OR gate, because you have to perform OR operation between these two terms, OR operation between these two terms, and OR operation between these two, right? So here what I'm going to do, I'm going to write OR here, and so that is this one. Which one it is? This one. This OR gate. Now I'm going to draw OR gate for this term. So this is one OR gate. Now I have to draw OR gate between these two, right? So between these two I have to draw one more OR gate, right? Now this is Y, right? Now you just see here how many gates are there. So now you have to tell me how many ICs we need to take. So first let us count NOT gate in the circuit, right? See here I have 1 and 2 NOT gates, right? So I have only 2 NOT gates. And how many AND gates? 1, 2, 3, 4. 4 AND gates. 4 AND gates. And I have 1, 2 and 3 OR gates. 3 OR gates. So here this is a 2 input. This is also 2 input. Now you have to tell me how many ICs are required to rig up the circuit, right? So in one IC, NOT IC consists of 6 gates. OR IC of 2 input consists of 4 gates, right? And IC, which is of 2 input, consists of 4 gates, right? So just to observe here, see here I have 4 OR gates in one IC, which is of 2 input, and 4 AND gates in one IC, which is also of 2 input. If it is 3 input, I will be having only 3 gates. So you can observe here, for in this IC, this is for 3 input. I have 3 AND gates, right? So in this IC, you can observe there are 4 AND gates in one IC, right? Now this is a 2 input. This is a 2 input, right? So AND gate, OR gate, both we have 4 gates in one IC. If it is a NOT gate, we have 6 NOT gates are available in one IC. See here, in one IC there are 6 NOT gates. Now, so for this circuit, so this is the gates required to rig up this circuit. Now how many NOT ICs have to take? NOT gate IC have to take 1, and gate IC how many? See here I have only 4 AND gates. In one IC there will be 4 gates, so I have to take only 1. And OR gate, or see here I need 3 OR gates in the circuit to rig up this circuit, but in one IC there will be 4 OR gates. So out of 4 I am going to use only 3. So how many ICs are required? Only 1. So here 3 ICs are required. One is NOT gate IC, that is 7404, and one AND gate IC 7408, and one OR gate IC, that is 7432, right? So this is how you have to find out how many ICs are required. Now I have to write the pin numbers for the IC, right? Now I have to write the pin numbers for the IC. So how to write the pin numbers? I'll teach you now, which is very important, right? Okay. Mm, okay. So, you observe in the NOT gate IC. In the NOT gate IC, I am going to see for my circuit, I need only two NOT gates. You can use this first gate or second gate, or you can use this fifth gate and uh, which one? Third gate. Any two gates you can use, but the pin number should be correct, right? The pin number should be correct. If you are using this third IC, third gate and fifth gate, you have to write pin numbers input as 5 and 6 as output, and if you are using fifth one, then pin number 11 is the input, pin number 10 is the output. But now I am going to use so just to avoid confusion, I am going to use first gate and second gate, right? So the first gate, pin number 1 is the input, 2 is the output. And for the second gate, 3 is the input, 4 is the output. Right? I'm going to write that here now. So here I'm going to use pin number 1 input, pin number 2 output, 3 input and 4 is the output for the NOT gate. Likewise, I have to write the inputs for the AND gate as well as OR gate also, right? So this is the AND gate. Since I'm using all four, just remember I'm going to use all four gates of this IC. Pin number 1 to input, 3 is the output, 4 5 input, 6 output. Likewise, 9 10 input, 8 output, 12 13 input, 11 output, right? So same thing I am going to write now for the AND gate in the circuit, right? So here pin number 1, 2 are the input, 3 is the output, 4, 5 input, 6 is the output, 8 is the output, 9, 10 are the input, 11 output, 12, 13 are the input, right? So the pin numbers of two input target is also same. So I'm out of four gates I'm using only 1, 2 and 3. So I'm using first one, second one and third one. I'm not using this fourth one because for my circuit I need only 3 gates, right? So here I am going to write the pin numbers for that. It is pin number 1 is the input, 2 output. Sorry, pin number 1 and 2 are the inputs, 3 is the output of the first gate. Next, pin number 4, 5 are the input, 6 is the output. Next, pin number 8 is the output, 9 and 10 are the input. So this is how you have to write the pin numbers for the circuit, right? I hope you have understood this. See students, in the last class, this is the expression which I've written, right? So for this expression, this is the logic circuit, right? So using basic gates, so this is the circuit using basic gates. So equivalent NAND implementation circuit is this. So here just to make you understand, I've marked this. So here this is belongs to first gate here I have written, and this is belongs to second gate, and see here I have written gate number 1 2 and here it is 3, this is 4 and this is 5. So everything I have mentioned here just to make you understand, right? So as I've already told you, if two inverters are back to back in the circuits, I can remove that circuits from the remove that inverters which are back to back in the circuit. So if you observe carefully, I have this gate, two gates which are back to back, and I have these two gates which are back to back, and I have these two gates which are back to back, right? So I have to remove this inverters which are back to back in the circuit. Next, I have to redraw the circuit, right? So, how it looks if I redraw the circuit. Now say students, if you redraw the circuit, see this is the circuit when you redraw after removing the inverters which are back to back from the circuit, right? So here if you observe carefully, so for this basic circuit, it requires how many gates? One NOT gate IC and one AND gate IC which is of two input because I have two gates. Out of four gates I'm going to use two. But here I have one more gate which has three inputs, so I have to take one more AND gate IC which is of three input, and for this OR gate I have to take one IC which is of three input, right? So here to rig up this circuit I need four ICs. So if I use same thing, if I implement using NAND gates, how many ICs are required? See here, for two inputs I have 1, 2 and 3. So if it is two inputs, actually in one IC there will be four gates, so I need only one NAND gate which is of uh, two input, and here I have two gates which has three inputs and one more NAND gate which is of three input, right? So here I need only two, but here I need four, right? So but if I rig up the circuit, I can achieve same function of, of this basic gates, right? So this is the NAND implementation. That is why this is called universal gate. We can achieve any function of the basic gates, right? So here, let me discuss how the same thing can be implemented using NOR gate for the same expression. Let me go with it. Right, so what is the expression? Y is equal to AB bar plus BC plus ABC. First I have to draw A, next is B bar, next is B and C, next is ABC, right? So for ABC, I'll take another color. So this is A, this is B, and this is C, right? So this is the circuit. So I have to implement this using NOR gate, right? So what is the AND equivalent NOR gate? I've already discussed in the last class, students, right? So here you have to draw like this for AND gate equivalent NOR gate. So this is for the first one. But here for the second input, I have one more inverter here. So I'm going to draw one more inverter and I'm going to label it as B, this as A. Next, I have one more gate. This is second and this is third gate, which is also an AND gate. So AND gate equivalent NOR gate is this. So this is for the third gate. One input is from B and another input is from C. And I have one more AND gate, that is fourth gate, which has three inputs. So I'm going to write like this. Three inputs, right? So here one input is from A and another input is from, one is from A another is B, and another input is from C. Next I have OR gate. So for the OR gate, I am going to write like this. This is the OR equivalent NOR gate, right? So this is Y. Now in this circuit, I have to check which are the inverters which are back to back in the circuit. So if you observe carefully, I have only this thing which are back to back. So I have to remove those two inverters from the circuit and I have to redraw the circuit. Now I am going to redraw the circuit and I am going to remove these two inverters from the circuit, right? So this is A, B. I have to remove those two inverters and directly I have to write like this, and this gate is this one, right? Next I have to write B and C. This is B, this is C, B, and this is C. This one I am writing, and last ABC I have to write. So for A, B, C, A, B, C, this is the equivalent. Next I have to write this part. This is Y. Here I am going to connect ABC here. I have to connect ABC here. So this is A and this is B and this is C. This is the circuit. As we have discussed for the NAND gate here, to recap this circuit I need total 4 ICs, 1 and 1 OR and 1 not and one more and of 3 input. So this is also 3 input and this is 2 input. Now same thing if I realize using NOR gate. So here count how many gates are there of 2 inputs. 1, 2, 3, 4, 5, 6, 7, 8, and this is 9. 9 NOR gates of 2 input, right? And how many 3 inputs? So this is 1 and this is 2. 2 gates are of 3 inputs, right? So here to get this 9 gates I need 3 NOR ICs of 2 inputs, because since it is 9, I will connect 4 gates of first IC, 4 gates of second IC, and only 1 gate in third IC, and remaining 3 will not be used from the third IC. So 3 NOR gate ICs which is of 2 input and 2 gates are required of 3 inputs. So one more IC of NOR, but it is 3 inputs. So here to realize this I need how many gates, how many ICs? For NOR gate also it is 4, for basic gate also it is 4. But if you see here, NAND gate it need only 2, right? Basic gates ICs required for NAND it is 2, and NOR it is 4, right? So that is why, see here, basic gates 4, ICs are 4, NAND is 2, NOR is 4. So here if you compare this, here NAND implementation is better. So whatever the ICs you are going to use in the lab, all ICs are made up with NAND gates, because when compared to NOR gate, the number of gates or number of ICs required in the NAND are very less. That is why most of the ICs are made up with NAND gates. Students, now I am going to wind up this session. I'll continue in the next class.